Hello students, today we are going to start unit number 4. This is the continuation to unit 1 and we are going to see force, magnetic and heading sensors in this unit. Unit number 4 we are commencing today and we are going to complete this in another 6 to 7 hours classes. So here we are going to start with the force measurement. The first topic under force measurement is strain gauges, and we can have a load cell also. Load cell is made up of strain gauges, and how they can be constructed, that we are going to discuss here in this session. So these are the topics. I have splitted this unit into different topics. Each one in each session we can complete this. Strain gauge and load cell we shall complete in this session. Strain gauge is a resistance when changes under application of force or strain. So resistance is subjected to change when you apply either force or strain, used for measurement of force, strain, stress, pressure, displacement, acceleration, etc. It consists of file of resistive characteristics which is safely mounted on a backing material. So there will be a backing material on which the resistance element is pasted or mounted. When a known amount of stress is subjected to the resistive file, the resistance of the file changes accordingly. So this change in resistance is directly proportional to applied force. Establishes a relation between the change in resistance and strain applied. This relation is known as quantity called gauge factor. So this is the relation between the change in resistance to the strain applied is known as gauge factor. The change in resistance can be calculated with the help of Wheatstone bridge. So Wheatstone bridge circuit is very useful to find out the change in resistance. Strain gauge application, you have diaphragm pressure gauge. So pressure is made to enter in this channel, and now this is the diaphragm. Now, when you mount a strain gauge on diaphragm, this strain gauge will experience the change that is the force, the pressure. When pressurized fluid is entering in this channel, there will be the pressure will act on the strain gauge as well. When it is acting on the strain gauge, there will be change in resistance in the strain gauge. So this is one of the applications, and this is strain gauge load cell. And here these are the platforms through which we can apply the load, and this can be used as weighing machine as well. So the strain gauges are mounted on circumference of the this column, and so if you see from top, these are the R1, R2, R3, R4 resistance, and this is the three-dimensional view, and strain gauges are mounted on circumferential surface. So this is the strain gauge. You can see here. This is the grid length here, and this is grid width, and this is the backing material. And you have cover. It is covered with backup material, backing material, and you have carrier here. And this is the measuring grid. It is the resistance element, and you have leads. So two leads are connected to this resistance element, and this is the construction, simple construction. And this is the Wheatstone bridge, and here R1, R2, R3 are known resistors are employed here, and Rx is the strain gauge element, and this is now unknown resistance, and any resistance, unknown resistance with known three resistors, it can be easily find out. And the potential difference between these two terminals, that is D and B, is measured using a voltmeter or a galvanometer, and power supply is given to A terminal and C terminal. So this is the simple circuit, Wheatstone bridge circuit, and this is the actual strain gauge. So this is the backing material on which the file is mounted. There are four resistors connected as a bridge circuit. The three resistors R1, R2, R3 will have known values. The value of resistance Rx will be unknown and has to be calculated. The value of R2 is adjustable. A galvanometer has to be set between the points D and B, as we see in the construction in earlier slide. The property of the strain gauge depends on the size, shape, and electrical conductivity of the conductor used. Types of strain gauges. This is the broad classification: mechanical strain gauge, optical, electrical, and we are concentrating on only electrical strain gauges. Again, these electrical strain gauges are wire gauges, some semiconductor gauges. Again, we are concentrating on wire gauges. These wire gauges again splitted into three groups. One is bonded gauges, unbonded gauges, and foil gauges. Depending on principle of operation and constructional features, we have three types as we see in the classification diagram. Mechanical strain gauge, it is not required for our syllabus. Still, I am showing you this mechanical strain gauge. It is Hagenberger type extensometer. So extensometers are topics in metrology subjects. Definitely, you could have come across this extensometer. It is a mechanical type strain gauge. Next, we have optical strain gauge. It is Marfin's mirror extensometer. It is again a type of extensometer only. This is also one of the important topics in metrology subject. You could have studied this extensometers there. Just I am giving you examples here. Electrical strain gauges. So these electrical strain gauges we are seeing all along, and we will see the theory of strain gauge. The principle: the electrical resistance of conductor changes when it is subjected to mechanical deformation. Resistance of conductor R equal to rho L by A. L is the length of conductor, A is cross-sectional area of conductor, rho is resistivity of material. When you differentiate this partial differentiation, dou R by R, dou rho by rho, dou L by L minus dou A by A, and the area is related to the square of some transverse dimension diameter denoted by d. So dou a by a is equal to 2 dou d by d. So we are just converting into in terms of diameter, and therefore now if you replace this in place of dou a by a, it is minus 2 dou d by d. So this is the equation for resistance, and now this will become like this. So the gauge factor can be find out using that relation. It is defined as the ratio per unit change in resistance to per unit change in length. Gauge factor G equal to delta R by R, that is change in resistance by change in length. So that is axial strain. Dou R by R divided by axial strain. So dou L by L equal to eta A or epsilon A, this is known as axial strain. Dou d by d equal to epsilon L, that is known as lateral strain. And we know the Poisson's ratio, that is V equal to minus dou d by d, that is lateral strain by axial strain. It is a dimensionless quantity. Poisson's ratio is a dimensionless quantity. After solving for gauge factor, so this equation, so after solving for gauge factor, here G equal to 1 plus 2V, that is Poisson's ratio, dou rho by rho divided by dou L by L, or this can be represented in this form also. G equal to 1. 1 is the resistance change due to change in length. So that is 2V, that is Poisson's ratio. Resistance change due to change in area. Dou rho by rho by the axial strain, that is resistance change due to change in resistivity or piezo resistance effect. So this is the gauge factor equation. A small derivation, but derivation, a very simple derivation, right? You can derive and you can get the gauge factor equation. The value of the resistance of the gauge and its gauge factor is specified by the manufacturer. Whenever you purchase strain gauge, the gauge factor will be specified with it. If resistivity rho does not vary with strain neglected, for physical typical value of V equal zero point 0.5, gauge factor equal to 2. So this is one example. The strain E usually measured in terms of microstrain. 1 microstrain equal to 1 micron by meter. Resistance wire type: bonded strain gauge, unbonded strain gauge, and file strain gauge. These are the three types, and we'll see what are the differences between these three. A bonded strain gauge: the strain gauge is bonded on the surface of specimen being tested by using thin adhesive cement. So here the file, that is the file, is just pasted on the surface, and that surface itself will act as backing material. The strain gauge is a grid of fine resistance wire. The wire grid may have shape of square, rectangle, circle, or rosette type. The surface area of the wire section is kept larger than its cross-sectional area to avoid stress relaxation and slippage. The wire gauges may be fabricated in four basic varieties: flat grid, wrap round, single wire, or woven type. The wire grid is mounted on backing paper. So this only backing paper is used to mount this wire grid, and that is obviously pasted onto the surface for which you wanted to measure either strain or force or pressure. Unbonded strain gauge, there is no backing material. It is a free filament sensing element which strain is transformed to resistive wire directly without any backing. So just a loose wire is used. Number of loops of high tensile strength resistance wire is wound so that winding experiences an increase or decrease of stress for a given force input. So advantages of unbonded strain gauge: because of its radial symmetry, spurious transverse forces are cancelled. So whatever transverse forces are generated, they will be automatically nullified. Very low hysteresis and creep. Force summing and force sensing components can be integrated. Disadvantage: problem of fixing the at a place of measurement and its applications. Unbounded strain gauges are used in displacement transducer, pressure transducer, and accelerometers. So even accelerometer can be it can be used as accelerometer as well. File strain gauge: file gauge uses very thin metal file of larger area compared to its cross section. The file is used as sensing element. File can be easily fabricated in different shapes such as circular gauge, diaphragm gauge, spiral gauge, rosettes by using photo etching process. So file gauge advantages: higher heat dissipation capability because of large surface area, better thermal stability, excellent strain reproducibility because photo etching process, more flexible as file in is very thin, and available in different shapes and sizes, convenient for measurement of localized strains. These are the advantages, and these are the three types of wire strain gauges, and we are seeing the differences characteristics now. Gauge factor, these are the characteristics, or we can say properties as well. Gauge factor: gauge resistance, linearity, breaking strain, fatigue life. You have temperature compensation. So these are the temperature compensation is also required. Gauges may be obtained with coefficients of thermal expansion that match general purpose steels, stainless steels, and aluminum alloys. Compensation for thermal effects may also be obtained by using the bridge circuit. Even this temperature compensation can be done using bridge circuit also. So these are the characteristics. These are the textbooks on which you can rely, and uh, e-resources. And this topic we are concluding here. And any doubts, please meet me in our Wednesday and Thursday regular classes. You can definitely, I will clarify all your doubts. Thank you, students. We stop here. We will start the next topic in next session. Thank you.